Welcome to this video. This is lesson 3 of our unit 7 rational functions, and we're going to talk about asymptotes. Our agenda for this lesson, we will cover graphing rational functions, asymptotes, and excluded values. We're going to do some practice questions, and then I'll leave you all for the IXL work. Our objective, scholars will be able to find the vertical and horizontal asymptote of a rational function. And our unit big idea is still rational functions. Here's our guiding question for this lesson. I know in a fraction that the bottom can never equal 0, but why? And how does that play out with rational functions? For example, the fraction 1 over 0 is impossible, but how does that play out when we have polynomials in the numerator and denominator? That's what we're going to talk about. So recall that a rational function is when we put two polynomials together in a fraction. So like this example here, you see p of 1 of x is the first polynomial and p2 of x is the bottom one. Remember that a polynomial is just anything with like some x terms in it. Cubic, quadratic, linear, all that stuff are considered polynomials. It could even actually be a number, something like this. So that's to remind you what a rational function is. What does a rational function look like when it's graphed? To answer that question, we're going to take this most simple rational function, y equals 1 over x. And let's create a table. So let's let x equal 2, then 1, and 0.5, 0.25, 0.125, and 0.0625. If you'll notice, it's just getting smaller and smaller and closer to 0. Now, if we plug these numbers into our function, the first one would be 1 over 2, which is 0.5. The next would be 1 over 1, which is, of course, 1. Then 1 over 0.5. That actually gets bigger, and that's 2. And then 1 over 0.25, that's actually 4. So on and so on. You see how this process continues, and you can see on the right hand side that it's growing. So as our x is getting closer to 0, our y is getting bigger. Our y is actually going to infinity. So you can see that on the graph over here. As x gets closer to 0, y shoots up. And it's the opposite way if you're going the opposite direction. If you go away from 0, in other words, x is getting bigger, then you're getting a fraction with a bigger and bigger denominator. 1 over 100, 1 over 1000, so on and so on, and your y is going to get smaller. And you have an identical reflection in terms of the negative numbers. When you are approaching negative, your x is getting large negative, your y is just going to get closer and closer to 0. And then same thing, if your x is getting closer to 0 from the negative side, your y is just going to shoot down to negative infinity. So here's some important vocabulary you need to know. An excluded value or vertical asymptote is whenever the bottom polynomial equals 0. So remember at the beginning our guiding question is what happens when the denominator equals 0? Well, in this case you get something called an asymptote. And if you look at the graph over here, the vertical asymptote is right here. It's just this straight up and down line right at x equals 0. Vertical asymptotes are always going to be in terms of x. So x equals 1, x equals 2, x equals something. That will be your vertical asymptote. And notice in this case that the graph gets really, really close, and it's actually going to get infinitely close to this line, but never actually touch it. So that's what an asymptote is. How do you figure it out? If you're just given the equation, you need to figure out when does the bottom polynomial equal 0. That's how you'll know what the equation of your asymptote will be. When it comes to a horizontal asymptote, you're actually going to calculate what happens as x goes to infinity. So over here on this graph, the horizontal asymptote is this line going from left to right, and the equation of that is y equals 0. Now you can figure it out just given the function by seeing what happens as x gets really, really big. What does the function approach? That will tell you what the horizontal asymptote is. So let's try some practice questions. Look at this graph. What is the equation of the horizontal and vertical asymptotes? So we can see right away that this graph is approaching this line here, but never actually going to cross it, and approaching this line here and never actually going to cross it. So you know that your vertical, remember vertical is up and down, and you can remember this because V kind of looks like an arrow. Vertical is going to be x equals 0. Vertical x, vertical x. And then our horizontal here is going to be y equals 0. Is it always going to be 0? No. you may have different numbers. This whole graph could be shifted over, in which case you're just looking for where does it approach? What line does it approach? In this question, just like the previous one, we're asked to find what is the horizontal and vertical asymptotes, but notice now that the graph is shifted. However, the approach is the same. This graph right here is closely approaching this vertical up and down line, and it's right at -5. So I know that my vertical asymptote has to be x equals -5. So that's my vertical. And then my horizontal is going to be right here. This is what this graph is approaching, which that is going to be y equals 0. So those are my horizontal and vertical asymptotes. Alright, in this question we're asked to find what is the excluded value. To do that, we need to know when is this denominator polynomial going to equal 0. So let's set it equal to 0 and solve that. X plus 1 is 0, which is minus 1, and you see that x has to equal -1. So we know that our excluded value has to be -1, and our vertical asymptote is x equals -1. In this question we're asked, what are the equations of the vertical and horizontal asymptotes? So we need to do what we did before, figure out what this denominator can't equal by setting it equal to 0 and solving, and we see that we get +6. So I know my vertical, because vertical is x, is +6. Now let's find the horizontal. What happens when x approaches infinity? So as this x right here gets very, very big, this fraction is going to get very, very small. And in fact, it's actually going to go to 0 eventually, which leaves us with 7 left over. So our horizontal asymptote is y equals 7. It's usually just going to be whatever this number is out here, just so you know. Alright, that was it for this lesson. Here's the IXL for you to do. Algebra 2 in 1. Please be sure to send me an email or join me during my office hours on Zoom with any questions. Best of luck.